Alright, let's take a look at one more quick example of a hypothesis test for the difference between two proportions. Let's take a look at the seatbelt use problem. In a survey of 480 drivers from the south, 408 wear a seatbelt. In a survey of 360 drivers from the northeast, 288 wear a seatbelt. At alpha equal 0.05, can you support the claim that the proportion of drivers who wear seatbelts is greater in the south than in the northeast? Okay, so I went ahead and wrote out a few of the steps beforehand just to save some time. Okay, the claim is that the proportion of drivers who wear seatbelts is greater in the south than in the northeast. Okay, so that would be P sub 1 greater than P sub 2. Okay, so this makes this an upper tail test, and the alternative is the claim. Okay, and then I summarized the information. Okay, there were 408 drivers out of 480 that wore their seatbelt in the south, and for the northeast there were 288 out of 360. Okay, so to get this information, the test statistic and p-value from the calculator, okay, we go ahead and press on stat, right arrow over to test, and we want to select the two proportion z-test. Now, I didn't do the step where we check the assumptions, okay, where we have to find the pooled proportion. I did that in the previous example, so I just went ahead and did this test assuming those assumptions had been met. However, I do ask for that in your lab, so make sure you understand how to go through that step. Okay, so after I select two proportion z-test, you go ahead and select or input the information. I went ahead and changed the direction of the alternative, and then press calculate. Okay, so I got a standardized test statistic of about 1.90 with a corresponding p-value of about 0.029, okay, with some rounding. Okay, so I'm using a level of significance of 0.05. So this p-value is less than or equal to that, so I'm going to reject the null. So the question is, can you support the claim that the proportion of drivers who wear seatbelts is greater in the south than in the northeast? Okay, because I'm rejecting the null in this problem, I am supporting the claim. Okay, so there is sufficient evidence to support the claim. Okay, this is the boring part. Okay, and then you could finish that by writing it in terms of the question. Okay, so support the claim that the proportion of drivers who wear seatbelts is greater in the south than in the northeast. Okay, now this is using the p-value method. Okay, I can go ahead and use the critical value method by sketching the distribution, shading my area of rejection. Okay, this is an upper tail test, as indicated by the alternative. And I could use my inverse normal function here, okay, by going to distribution. And I want to select a cumulative area of 0.95, or input a cumulative area of 0.95. Okay, so that gives a critical value of 1.645. Okay, so looking at where this test statistic lies with respect to the critical value, I'm out here in the rejection region. Okay, so we saw that with the p-value. Okay, so the p-value represents this area here, the smaller area. Okay, clearly the smaller area from our test statistic to positive infinity is less than the amount of area from our critical value to positive infinity. Okay, so you need to be getting the same conclusions whether or not you use the p-value method or the critical value method. Okay, so lastly, because we rejected the null hypothesis, it is possible a type 1 error may have occurred. Okay, what's nice about using the calculator for the two sample z-tests, just one more thing, let me go through the steps and calculate again. It does give this pooled proportion. So one thing you can do is you could go ahead and go through the steps, get that pooled proportion, then check the assumptions, and then go ahead and write the decision and so on. Okay, or you can go ahead and find that pooled proportion by hand before going into the test.